welcome back to Learn with Aksha. This is Aksha Ruben. In today's video, we're gonna see delta to star conversion. To begin with, how do you find the resistance of a resistor connected in star? So there's a formula: product of adjacent resistance in delta divided by the sum of resistance in delta. For example, if you have to find the resistance of the resistor R1, you do the product of adjacent. So if it's R1, it would be here, and the product of adjacent would be RB into RC divided by the sum of resistance, that is RA plus RB plus RC. That's exactly what is written here. This is the formula. Similarly, you can find the resistance for R2 and R3. You'll understand it better while we do the problems. Here comes the first problem. Convert the delta circuit to star. Here's the delta circuit. You have A, B, C. There are three resistors and resistor R1 with 10 ohm, R2 with 60 ohm, and R3 with 30 ohm. Let's get started. First, you have to draw the equivalent star connection. For this delta, you draw the equivalent star connection. So there is A, B, and C, three resistors, RA, RB, and RC. So this is a star equivalent. You draw it, and then you have to insert the star connection into the delta circuit. So there is a delta circuit. You gotta drag and put the star into this delta. So this is how it will look when you put the star into the delta connection. Now it's much easier to find the adjacent sides. That's why we're putting it inside the delta circuit. Now we have to find the equivalent for, first let's find RA. This is RA. This resistance that is pointed out by the laser is RA. Now the adjacent of RA would be this and this. So adjacent is 10 ohm and 60 ohm. So what's the formula? Product of adjacent divided by sum of resistance. So the product is 10 into 60 divided by 10 plus 30 plus 60. That's exactly what's done here. So you get the final answer, 6 ohm. So the resistance of RA is 6 ohm. Now you got to repeat it for the other resistance. So the resistance of RB, for RB, the adjacent is 60 ohm and 30 ohm. So the product would be 60 into 30 divided by 60 plus 30 plus 10, which will give you an answer 18 ohm. And then repeat the same for the last resistor, the third resistor, which is RC. So the adjacent for RC is 10 and 30. So it will be 10 into 30 divided by the sum, 10 plus 30 plus 60, and that will give you the answer 3 ohm. Now we have found the resistance of all three resistors. So this will be the final answer. You have to draw the star circuit and you write the answer 6 ohm, 3 ohm, 18 ohm. Here's another question. This is a much harder one. It's kind of the university question. So find the equivalent resistance in this circuit. You have to find the equivalent resistance for all the resistance in here. So in this question, as you can see, there are two delta connections. One here, 100 ohm, 125 ohm, and 25 ohm. And then there's another delta connection here, 40 ohm, 37.5 ohm, and 25 ohm. So there are two delta connections. And to solve this, you need to solve either one of both of this only. So here we are solving the first delta connection to a star. So we are converting the first delta connection to the star. First you have to insert the star connection into the delta, selected delta. So this is our selected delta connection and we have drawn the star into it. Then according to the formula, you find the resistance of each of the star resistor. So for this resistance, which is RA, the formula will be the adjacent. So product of adjacent is 100 into 25 divided by sum of all resistance, 100 plus 125 plus 25. That will give you the answer 50. Then for the this resistance, which is RB. So for RB, again adjacent would be 125 into 25 divided by 125 plus 25 plus 100. That will give you the answer 12.5 ohm. And then last for RC, which is this resistance, adjacent is 100 into 25 divided by 100 plus 25 plus 125, which will give you the answer 10 ohm. Now that we have found the resistance value for all the three resistance in the star connection, we can substitute remove the delta element and you can put the star connection itself. So like it was here, you just have to remove this 100, this 25 and this 125, and the remaining stays the same. So we have just removed those, and here's the star connection that we found. Next we need to solve this part. So there are two here connected in series and two resistance here which are connected in series. So we have to solve the both series resistance. Like here, for series resistance, the formula is R1 plus R2. So you simply do 12.5 ohms plus 37.5 ohm. You'll get the answer 50 ohm, and here you do 10 ohm plus 40 ohm. That will give you the answer 50 ohm. So now that we have solved both the resistance, you substitute the equivalent resistance, and that will look like this. Then you have to solve this parallel circuit, 50 and 50 ohm, both the 50 ohms. So we have to solve this parallel circuit. Or for parallel circuit, you know the formula, it's the product of both the resistance divided by their sum. So product of 50 into 50 divided by their sum, 50 plus 50, which will give you the answer 25. Now you can remove this and put the equivalent resistance of 25 ohms here. So when you do the 25 ohm resistor, now you can see all of the resistance are in series. The same current will flow through them, so they are in series. So you just simply have to add all the resistance to find their equivalent resistance. That will be 10 plus 50 plus 25, and that will give you the answer 85 ohm. Now you can replace all these three resistance with the equivalent resistance of 85 ohms, and that will give you the answer 85 ohms. So this is how you do such kind of problems where you have to convert from delta to star wherever required. If you see a delta connection in a circuit, you have to convert it into star for further simplification. So that's it for today's video. Thank you for watching. Do like and subscribe to our channel if you want to. Thank you so much. Bye bye. See you guys in another video.